So one of the problems that you're going to face in section 8.7 is this one here. I call example A. Now usually when you see something like this, you're just going to factor as the difference of squares. But what they're really looking for in, I think it's problem 4, is something a little different. They're asking you for what do you square to get each of these terms. So they're not asking you to factor it out all the way. They're just saying, all right, well, if you're going to go and factor this just a little bit, what's it going to look like? So it starts by recognizing that this is the difference of squares. What do you square to get 25? Come on, not all at once. And feel free to answer. 5. Yeah, thank you, 5. And then what do you square to get y squared? A y. Now we're going to play that same game over here. You square the 4. How about to get m to the 4th power? What would I put in here and square to get m to the 4th power? M squared. Perfect. And that's all they're looking for in, I think it was problem 4. So you don't have to overdo it. Now, down here, this one would eventually factor as the difference of cubes, but to start that, you've got to recognize that, oh, we're cubing something here. What do you cube to get an 8?
2.
2. And then there'd be 2 what?
H.
2h. Awesome, thank you. Now over here, same kind of thing. What do you cube to get 27?
3.
3, and then k to the 1st power is not going to work. What power of k do I need here? Second. Because remember, these exponents multiply. 3 times 2 would be a 6. So that's all they're looking for in that first one is, well, what do you cube or what do you square to get these various things? Now, a lot of these are going to ask you to go further. This one right here, let's do example B. This one's kind of a favorite for exams. So let me copy that down. 256 a to the 4th minus 625 b to the 4th. Now, if you're looking at that going, oh my gosh, those are just really big numbers. I don't know where to begin. Well, there's only 2 terms, and you're subtracting them. So it either could be the difference of squares or the difference of cubes. And if you're looking at that going, I don't know what I'd square to get 256, well, there's a nice way around it. Let me just exit out of this. But if you know what you square to get 256, do this. Take the square root of 256. And if it works out to be an even number, then 256 is a perfect square. Beautiful. So we'll put that in there as 16, and then a to the 2nd. You can play the same game with 625 if you're like, oh my gosh, that's way bigger than I know. Well, take the square root of 625 and you get 25 and realize, oh, okay, yeah, that works. So now you're rocking. We can put that in here, 6 squared minus 25, and then be b squared. And then 16a squared plus 25b squared. So we're looking good there, but you're not done. On the test, if you left it here, you would get 2 points out of 4. Why? This one factors some more. How come this one doesn't factor anymore? Bonus points here. Why doesn't it factor anymore?
Because of the plus sign.
Because of the plus sign. It's prime. Yes. So a couple voices on that one. Thank you. So 4a minus 5b, 4a plus 5b, and this one stays the same. 16a squared plus 25b squared. That's completely factored now. So we're looking good on that one. Couple more here. This is factor the expression, factor out any GCF first. I'm not going to be quite so nice as to say, you know, factor out the GCF first. That's something that you should know. So if I had 8x squared minus 512, obviously 2 goes into both of those, but does anything more? Well, yeah, you can actually factor out the 8, which is behind x squared minus, what would it be? Did I copy this down right?
64.
Is it 64? Yeah, okay, 64. For some reason, I was thinking 64, but couldn't get the math to work out as fast in my head as I needed to. In any case, this factors some more. Now the 8 stays out front, x minus 8, x plus 8, and you're done. Beautiful, beautiful. This one, example C, should be example D, I guess. Or the last one should have been example B. So example C, part 2. Example C, part 2. M plus n squared minus p to the 4th. Well, you've got to group this, you got to look at this thing as being one whole term. So it really does kind of fit the pattern of an a squared minus b squared. A squared minus b squared is going to become the easiest and most relied upon factorization, a minus b times a plus b. The thing that you've got to identify, and the thing that we practice in example A, is, well, what are you squaring to get that first term? What do I square to get this? It's the whole thing, m plus n. That's what you're squaring to get this term. What do I square to get the second term? Somebody said it. P squared. And now what changes sign is the stuff in between the a and the b, not this. So this is going to stay m plus n, and that'll be plus p squared. And you're done. So nice. The last one. Just want to practice a sum of cubes with you. So to start with, in example D, what would you do? So it's 4x cubed plus 256. Where should you start on this one? GCF, thank you. The GCF is 4, and it leaves behind x cubed plus 64. Then you want to look at that and see if you can factor that one. Well, it's not the sum of squares. Even though 64 is 8 squared, how come it's not the sum of squares? Yeah, x is cubed, right? So at best, it might fit into the sum of cubes formula. So this is, again, going back to kind of what we're doing in example A. You got to ask yourself, what do I cube to get this term here? Be an x. What do you cube to get this term? 4. Then you're going to take and say, all right, let's take the x and multiply it by itself. That gives me the x squared. 4 times itself gives me 16. And then x times 4, I'll write it as 4x. That gives me my middle term. Matilda, what's the word that I use to help me remember how to fill this stuff in?
So
Soap. Same sign. Opposite sign, always positive. Thank you. So, Marcel, what signs should I put in here?
Positive.
Positive here. Same. Good. Keep going, please.
Negative
Good.
and positive.
Perfect. There you go. All done with that one. So I'm hoping that these aren't too hard for you, and I hope the extra examples help out. Questions or comments on those few? All right. Good luck with this.